I welcome you to another series of our videos. So in this video, we will continue talking about vectors. So the problem we have here, or the question we have here, is coming from College Physics CUA 11th edition. This problem is a problem 62 and topic 1. So let's see what the question requires us to do. So the question reads, a person walks 25 degrees north of east for 3.10 kilometers. How far due north and how far due east would she have to walk to arrive at the same location? So this is the question at hand. So how do we understand this question? When we talk of a person walking 25 degrees north of east, we know that from the compass, if this is the compass, this is north, then this is east, then this is west, then this is south. So when we talk of northeast, then we mean that. So this if this angle here is 25 degrees, then this becomes our vector. So they are asking us to find how far due north and how far due east. So what they simply mean here is just finding the, so let's just write that as a vector on its own. So if this is a vector, if that is a vector, then they're asking us to find the x, if this is a vector, then how far due north? Then they are asking us to find the y component of the vector. Then how far due east? They're asking us to find the x component of a vector. So let's see how we can do it. So this is our diagram. Then how far due north? They want the y component of the vector. Then how far due east? They want the x component of the vector. So the angle, we've said it's 25 degrees. Then the magnitude, we've said it's 3.1 kilometers. So let's see how we can find the x component and the y component of this vector. So the x component, to find the x component, we use the equation x is equal to a cos theta. So we found that the a is the magnitude of the vector, which is 3.10. Then theta is 25. This is what is contained in the question. So when we punch this on a calculator, let's punch 3.0 cos 25, giving us 2.8095514 kilometers, which when we round off, or when we write in 3 significant figures, we get 2.81 kilometers. So this is the x component of the vector. Then to find the y component of the vector, we use this equation. Y is equal to a sine theta. A is the magnitude of the vector. Then theta is the angle, which is 25. So the magnitude is 3.1. So when we punch this on a calculator, we are getting 1.310116611 kilometers. So when we write this in 3 significant figures, we get the y component to be 1.3 kilometers. So we found what the question asked us to find. So due north, it's 1.31 kilometers. Due east is 2.81 kilometers. So we can prove if these components we found are correct by trying to reverse them back, or by finding the magnitude of the vector. So let's see how we can prove that, and also by finding the direction, which is the angle. We are just trying to prove here. So to find the magnitude of the vector, we use this equation: x squared plus the square root of x squared plus y squared. So these are just components of the vector. So when we substitute the components of the vector like this, then when you punch on a calculator, you get that. When you find the square root, so let's try to find the square root of 9.6122. It's giving us to be 3.100354818 kilometers. So when we can write this in two significant figures, so the resultant vector is 3.1. So it has taken us back to what the resultant vector is in the question. So hence we can say what we found, the components we found, the x component and the y component we found, are correct. Then we can also prove by finding the direction. So this is the formula: theta is equal to tan inverse y over x. So when you replace, then you punch on a calculator. Let's try to punch. We are getting, after punching, we are getting this 24.99456 degrees, which can be written in two significant figures to be theta is equal to 25 degrees. So at this point, we can also say that what we found is correct. So the x component of the vector is 2.81. Then the y component of the vector is 1.31 kilometers. So here it's kilometers. So at this point, we are done with the question. Thank you for watching. Remember to subscribe to our YouTube channel.